In this lesson, we're going to learn how to solve basic trigonometric equations. Now, most of this should be revision from last year, from National 5. So let's just take a look at some examples, because we've already covered all of the prerequisite knowledge in the previous lessons for this. So you'll be using either the graphs or the cast diagram to answer these questions as well. So example 1, solve sine x, and we can see we're working in degrees, equals a half for x lying between 0 and 360. So we could firstly look at the graph. So if you know what the sine graph looks like, write down a quick sketch, and well, where is sine x equal to a half? So we can put in the line y equals a half, and we can see there that that line cuts the sine curve at 2 points, and that's between 0 and 360. So we're expecting two answers here, one here and one here. So this is x equals something and x equals something here as well. Now you might immediately realise, well wait now, sine of 30 is a half. That was one of our exact values, so that will hopefully help you here as well. So we'll have a look at some working. So if you're happy using the graph, that's fine, but if you want to use a cast diagram as well, that's also fine. So we know that sine x is positive here, and sine x is positive in the first and second quadrants. Okay, so the inverse sine of a half is equal to 30, like I've already said. So in the first quadrant the answer is 30 degrees, and in the second quadrant it's 180 minus 30 degrees, which is 150. So our solutions here then are 30 and 150. And we can see from the graph that that's quite possible. We can see that our answers had to lie between 0 and 45. So that one in there, and that's a 30, and between 135 and 180. So again, we can see that that's 150 in there. So just now would be a good time to pause the video and copy down example 1. Okay, welcome back folks. Let's have a look at example 2 then. So we want to solve cos x equals negative 1 over root 5 for x lying between 0 and 2 pi. So you can see this time that we are working in radians. So like I've said before, it's very important when we're working in radians to stick to working in radians. Don't ever convert it to degrees and then back again, because if you forget to cross that out in the exam, you do lose marks. So the solution then, if we firstly just have a wee look at the graph. So here's the cos graph, which is lying between 0 and 2 pi. And if I just draw in the line y equals negative 1 over root 5, that's around here. Now I can see that that cuts the cosine graph in 2 points, which you can see here. So let's have a look at how to go about this. We can see that the two answers are occurring in the second quadrant between pi over 2 and pi, and the third quadrant, so between pi and 3 pi over 2. And that helps us with our cast diagram as well. Remember, that's where the cast diagram comes from, are the trigonometric curves to start with, so that's useful. So it's cos and it's negative, so that means the answers are occurring in the second and third quadrants, like I said, and you can see that here. So inverse cos of positive 1 over root 5 is 1.107. Now at this point you need to remember and have your calculator in radians, so you need to be able to change the mode in your calculator so that it's not displaying the wee d for degrees on your screen like you've always had to have up until this point, when you've been working with trigonometry throughout second, third year and National 5, you need to have the wee r. So if you're not very sure how to change that, either if you're in school, ask one of us, or if you are at home, you can maybe Google it if you've not got your calculator instructions on you. Okay, so inverse cos of positive 1 over root 5 is 1.107. Now, for the answer in the second quadrant, we need to have pi minus 1.107, and that is literally just using the pi button in your calculator. And for the third quadrant, it's pi plus 1.107. So putting those into our calculator gets us to 3 decimal places, x equals 2.035 and 4.249. And you can see here that one of our answers, obviously this is pi here in the middle, which is approximately 3.14. One of our answers is less than that, which is good, that's a 2.035 one. And one of them is greater than that, which is 4.249. So those are our final answers. Now, on to example 3. If you make sure you've got a wee copy of this. So solve sine x equals 3 for x lying between 0 and 2 pi. Now, if we just think for a wee moment about the graph of y equals sine x, I know this says y equals sine theta, but same, just a different variable, same curve that we're dealing with here. Now you can see here that that graph lies between -1 and 1, but we're actually looking for y equals 3. So that's the line y equals 3 here, and we want to see where that line cuts the sine curve. And you can see here that that actually doesn't happen, because the range of y equals sine x or sine theta, like I've said, is between -1 and 1. So there's no solution to this example, because, as I've said, sine x lies between -1 and 1. So no solution here, and you have to state that. If you're asked a question like that, you need to state that there's no solution and give a reason why. Again, folks, good idea to copy this one down as well. And finally, example 4. So we want to solve tan x equals -5 for x lying between 0 and 720. So I suppose, given the last example, the first thing that I might observe here is that, well, the last example was sine x, and we knew that there was no solution because the graph of sine x lies between -1 and 1. The same holds for the graph of cos x, but tan x is slightly different, so this is okay. We can have a number less than -1 and greater than 1, remember, because the tan graph lies between -infinity and infinity, so that's fine. The other thing I'm observing here is this range of values. Normally I'm solving between 0 and 360, or 0 and 2 pi, but this time I'm solving between 0 and 720 degrees, so that makes the question slightly different as well. So the solution then, we'll have a wee look at the graph first, and you can see here that this graph of tan x is lying between 0 and 720. And I'm just going to put the line y equals -5 in, and you can see here that that cuts the tangent graph 4 times. So we are looking for 4 different answers here. So, bring my cast diagram in. I can see instantly from the graph that one of my answers lies in the second quadrant, and one of them lies in the fourth quadrant. Okay, that's for between 0 and 360. So that's the second quadrant and the fourth quadrant, because tan x is negative here. It's equal to a negative number. So The inverse tan of positive 5 is 78.69 degrees. For our answer for the second quadrant, that's 180 minus 78.69, and for the fourth quadrant, 360 minus 78.69. So those two answers are 101.31, and we can see that is just past 90 and no more, so that's around the correct place, and 281.31, and again that's just past the 270 mark there. That red line is 270, remember, the asymptote. So now we do have two other answers to get as well. So if we just look at this one here, 101.31, if we add 360 onto that, that will get us this answer here. And that's 461.31, because remember the graph repeats itself. So all of the graphs of the trigonometric functions all repeat themselves after 360 degrees if it's just a single angle here. Okay, for the second answer, 281.31, if we add 360 onto that, we will get 641.31. And those then, folks, are our four answers to the equation tan x equals -5. Okay, so again, it would be a good idea to copy this one down into your jotter and then try the assigned exercise for today.